Hello everyone. I hope you're all doing well today. Today I'm here with a new science video for you guys. Today I'm going to be explaining the layers of the Earth plus tectonic plates and their interactions. Here you can see I have a diagram of the different layers of the Earth. First of all, there are 4 main layers of the Earth and 2 sublayers. The 4 main layers are the crust, the mantle, the outer core, and the inner core. The 2 sublayers are the lithosphere and the asthenosphere. The lithosphere makes up for the lower mantle and the upper crust and is strong and rigid and solid, whereas the asthenosphere is like the lower mantle, and it's the part of the mantle that flows with plasticity, and that's where the convection currents in the mantle happen. The layers can be compared to like an apple. The crust of the Earth is the thinnest layer, like the skin of an apple. Beneath is the mantle, which is the thickest layer of the Earth and is the flesh of the apple. The inner and outer cores, 2 separate layers, are the core of the apple, where the seed is. Here in the asthenosphere are the convection currents of magma, which influence the plate tectonics above them. Over here, I have a diagram of the different tectonic plates. You can see they all fit together like a puzzle piece, and most of them have one continent on them. For example, you have the South American plate, which has all of South America on it. The theory of plate tectonics describes how the tectonic plates of Earth move and interact. There are 2 types of tectonic plates, oceanic plates and continental plates. There are several differences in these plates, with one of the most important being that the oceanic plates are denser and thinner due to the weight of the ocean pressing on them, and the continental plates are much less dense. The difference of density can lead to oceanic plates sliding under continental ones, which can be responsible for the most powerful types of earthquakes in subduction zones. This is very rare, however. Here I have an example of one of the different plate interactions. This is a continental-continental convergent boundary, or a subduction boundary. There are 3 main types of interactions in plate tectonics. There are convergent plates, where they move together. There are divergent plates that are moving away from each other. There are transform plates, where they are moving in opposite directions but sliding past each other. Some of the friction that causes this creates earthquakes. The San Andreas fault is transform. A subduction zone is also a convergent boundary of oceanic and continental plates. This is where crust is destroyed and subducted into the mantle. This means that one crust is put underneath. Here I have an example of a mountain range. This is one of the types of landforms that can be created by tectonic plate movement. Every interaction of tectonic plates can cause either different landforms or hazards. Some landforms are mountains created by conversion, volcanoes, trenches, and mid-ocean ridges. The mid-ocean ridge is being created by seafloor spreading. Another important fact is that divergent plate motion in the middle of the ocean can create new crust, and at the same time, the crust at the edges of the oceanic crust is eaten by subduction. Tectonic plate movement can also create hazards such as earthquakes and tsunamis that are caused by undersea earthquakes. Here you can see over here on the left side you have Alfredwegener, and on the right side you have Harryhess. Both of these were extremely important scientists for the plate tectonics theory. Alfredwegener was a German scientist who came up with it, but the reason his theory wasn't accepted in the science world is that he didn't have a mechanism for seafloor spreading yet. Harryhess used sonar, was an American scientist who used sonar to discover that different landforms on the seafloor and prove that seafloor spreading was a thing. Alfredwegener came up with a theory of continental drift, but it was ridiculed by other scientists, and he died before it was accepted. Harryhess was the one who used sonar to prove the theory of continental drift by showing there are different landforms on the ocean surface as opposed to the flat surface that scientists used to believe. A Canadian geologist, John Wilson, was also the one who suggested the existence of hotspots where heat from the mantle rose up to create island chains, such as the Hawaiian Islands. Thank you for watching. If you have any suggestions for videos I should make in the future, please leave them down in the comment section. Thank you. If you enjoyed this video, please make sure to like, subscribe, and share my channel. Thank you. Bye.